rate of change that's driving continuous delivery in most organizations. Excuse me. An example of this that I like to talk about is that how many people have used mobile check deposit capabilities? So quite a bit. So in 2009, when this capability came out, it was sort of an edge case. USA Bank released it because they had a lot of soldiers overseas. They were, paying each other for gambling bets or other sorts of things, and they needed a way to deposit their checks. So, they came out this capability. Everybody else in the market goes, yeah, who would ever want to do that? It's like me in 2000 or maybe 1998, when I was looking at what at that time Sony Ericsson was doing with putting cameras in mobile phones. I said, who would ever want a bad camera in a mobile phone? Right? But innovation happens at a really rapid rate. In 2011, 1 in 4 consumers think that that's a really neat capability. By 2012, 65% of consumers would be willing to switch banks because if they didn't have mobile check deposit in the bank's mobile application. And then today, last year, I think 3,000 branch banks were closed because they're not needed anymore. So the rate of change in organizations, and this is just one example from the financial industry, the rate of change that application delivery is driving is huge. And we're going to see over the next 5 to 10 years at least this rate of change increase. Fortunes will be made and lost based on these kind of changes. So continuous delivery is really the engine for this kind of change. But you have to be able to ship fast, but it's not just shipping it the first time, it's being able to turn that thing around and keep improving it time after time after time. So, of course, the driver for this is largely starting with mobile applications, but then social media applications that need to be coordinated with mobile, cloud applications that need to be coordinated with that, and then back-end changes that have to be coordinated. So this isn't just a one application one time, or even one application repeatedly over time. It's coordinating application releases across multiple channels, multiple technologies, in basically perfect synchronization, because you've got to, if you've got a capability in your mobile device, you expect to go have that in the cloud device or in the website that you go to for that same organization. So this better experiences delivered faster ends up being the key. The problem is that organizations are struggling to keep up. So this is some data from just last year. It's improved a little bit, but so organizations, just for mobile devices, most organizations were doing 2 to 4 releases a year. And so if you think about, as a consumer, 2 to 4 releases a year is pretty slow. If you're in one of those organizations, you're probably saying, 2 to 4 releases a year, how can we possibly do that? But consumers basically are pretty fickle, and they're not very sticky in the sense that they can easily switch from one organization to the other. So if you're not delivering innovation at a fast enough rate, they'll simply go somewhere else, as the example with mobile check deposit was showing. So most organizations are trying to go faster, but they find a number of impediments to going faster. So most businesses now, and I think over time, this is one of the appeals of Agile to the business. They thought Agile equals fast. What they discovered was Agile really isn't fast, it's just different. So Agile with continuous delivery can be fast, but you've got to basically put in place a number of technological changes and cultural changes and skill changes in order to make that happen. But the benefits are essentially all based on feedback. So I've heard a number of different statistics quoted that the average application when it's shipped has something in the neighborhood of 30% of features that are never used, right? So that's, if we got earlier feedback that those things weren't interesting or weren't actually solving the real problem, we could have made better decisions. Another interesting statistic is that 85% of, roughly 80-85% of mobile applications are downloaded, used once, if at all, and then deleted. And so, I know that's the case with me, that, I download an app, sounded great, try it out, not so great, it's gone, because I've got limited space on my phone. So that getting fast feedback that you're building the right thing ends up being really important. So the more you can do that, the faster you can do that, the better you can, the better, in a sense, the investment that you're making in those applications is. So you've got lower waste, that leads to lower cost, Better feedback means better results. Doing that faster ends up putting you ahead of the competition. I was at a conference a few weeks ago, and this is an old joke about the bears and the backpackers and the bear, where two backpackers are walking down the trail, and one of them, they see the bear off on the distance, or actually very close, and so one of them throws down his pack, pulls out his running shoes, and starts putting it on, and the other guy's laughing. What are you doing? What are you doing? And you can't outrun a bear. They can run 35 miles an hour. And the guy says, I don't have to outrun the bear. I just have to outrun you. Right? So that the similarity is that being ahead of your competition is really the game here. It's not really objectively how fast you're releasing. It's how fast are you releasing relative to your competitors. But your competitors are probably in similar kinds of meetings, if not actually here today. And so they're also trying to learn how to deliver faster. So leading organizations, as Andres alluded, most of you probably know because you're here, are using a different approach. So rapid feedback driven by continuous delivery gives you the ability to adjust faster. Eric Ries in the Lean Startup calls this pivoting, right? So and that's become a common term now, being able to pivot faster. And so the ability to drive faster releases and pivot faster is based on a number of other kinds of things. So one of them is small batches. How many of you, is that a familiar term for many people, some people? Okay, so that's going to be a big thing when you look at the Phoenix Project, because they talk about driving smaller batches of work. This is a term that came out of lean manufacturing. So basically, it's doing small chunks of things, delivering that, gathering feedback, and then doing other small chunks of things. And based on the feedback, you may choose to do different things, and that's a good thing. The other thing is breaking down silos between organizations or between different parts of your organization. So that's another key aspect of the Phoenix Project, is looking at how these different organizational silos interact, or in fact don't interact, in the interest of pursuing excellence for the customer. Things like less planning, more doing, and I've heard the term from some clients, committing by delivering as opposed to committing by planning. And so all of these things, ultimately, I love this quote from William Gibson: the future's already here, it's just not evenly distributed, right? So people are doing this. And Gene Kim talks about these companies as being, and similar ones, as being unicorns, right? They're so rare, they're almost mythical. But the reality is that the things that they're doing are actually pretty simple. They're just doing it at a massive scale. And the rest of you can do these same kinds of things. Now, it's going to take you a while before you can do it at the same scale that these companies do. But I'd like to point out that 15 years ago, Amazon looked a lot like a traditional company. They had monolithic applications. They delivered at a relatively slow rate of speed. They had siloed organizations that didn't talk to one another. And about 10 years ago, things started to change. One of the big changes was this infamous email that went out that says, you will use services to talk between different parts of the organization. But another part of it was just that they started breaking down their applications into smaller chunks, smaller components, service-based, and increased the independence of each of the teams. So anyway, without making this a case study about Amazon, it's that other people are doing this. Other people have done it. It's proven, it works, and the challenge is getting there. So a couple of ways to look at this problem, and again, this is something that Gene talks about a lot in the Phoenix Project, of looking at this as a lean value delivery stream. And the way to do that is to lay out everything from when an idea is proposed to when you actually get customer value, and look at every single activity that happens along that path. And how long does it take to perform each of those activities? So here, this is a really hyper-simplified example, but you break down and look at how much work time does a task take, but more importantly, how much wait time is there between these different activities. And what you'll often find is that the wait time exceeds the actual work time. So then you ask yourself, what can I do to reduce either wait time or work time? And the process of improving is really a matter of taking each one of these things, taking this value delivery stream, and looking at where you have different blockages and systematically removing them. You don't have to do it all at once. That's the other thing. Steve and I were talking earlier about, we've learned that big batches of work don't work in software. We end up with lots of waste, lots of work in process that gets invalidated when we get feedback. So why would we do that for organizational change? Why would we do big changes? Because that's disruptive in a bad way. We talked today about disruption being in a good way, but that's disruptive in a bad way. So small incremental changes at every step of the way. Now there are some inflection points where you have to do things radically differently, but for the most part you can get started in a very incremental way. So my colleague Glenn O'Donnell and I wrote a report earlier this spring, and we called it the 8 Tenets of Faster Application Delivery. And basically what we found in talking to organizations is that there were 8 consistent things that organizations did. Now, most of them are simple in concept, harder in application, but 8 consistent things that they did that improved their application delivery capabilities. And most of them we'll talk about today somewhere on the agenda. So creating a delivery pipeline, visualizing that end-to-end process to go from idea to customer value. Second thing, break down big batches of work, break down big efforts into small batches. Automate the delivery pipeline. That's largely where continuous integration fits in, but also continuous testing and release automation, automating provisioning. And things like treating infrastructure as code, being able to spin up environments quickly, big part of that. Automating using continuous testing practices, big part of it. The final 2, eliminating the release drama, is that if you've got 100% automation coverage on your tests and you feel very reliable, you feel it's very reliable because you've been doing continuous integration, continuous testing all the way up to the release, it makes the release decision pretty much a no-brainer. Why wouldn't you release it? It's stable. You've deployed it a lot of times before into testing environments. It's not going to break things, and so releasing becomes no big deal. And then finally, once you've got that capability, or as you develop that capability and can drive faster feedback cycles, that improves business decisions. So I'll go through a few of these. I want to leave some time for questions. Just do a time check and see where we are. Okay. So a couple things to think about. So I've talked about this idea of small batch, and Gene talks about this a lot in the Phoenix project. It's really a matter of breaking down big chunks of work into small chunks. And so Agile practices usually, that's become the really popular way to break down that work. And so essentially you're taking, instead of doing a big requirements document, you've got a small backlog, a backlog consisting of small items, and then you pull things off that backlog in small chunks, develop them, get feedback, at least from internal users, if not from customers. And you drive that loop, and that by itself has a lot of benefit. Now, here we go, one more. So then the other piece of it, as we found in organizations, as they adopt those Agile practices, they immediately run into a problem. And that problem is that they don't have a dev environment, or they don't have a test environment. And one organization that I've talked to, they took, because of their request process, they'd spent years in operations implementing things like idle, and I don't mean to bash idle, but the problem was that it took 60 days to go from environment request to when you actually got an environment, 60 business days or 3 months. Well, if you can't get an environment for 3 months, what are you going to do? You're going to write requirements, right? You're going to do design. You're going to do all this other stuff. And what does that result in, in the Phoenix project vernacular? Well, it's work in process. What happens when you find out that requirement wasn't exactly what the user needed? All that work in process is waste. So if you don't have an environment, you can't really implement these practices. So getting environments spun up quickly ends up being a big part. Now, I apologize for the eye chart. This looks great in a webinar when it's in front of you on the screen, but I'll just talk to a few of the concepts. Is that there's a continuous delivery cycle that starts with that small batches of work that then basically you've got developers who then tackle it, build something, they deliver it into their source code environment. That then gets built and start testing it through continuous integration, all the way up from unit tests all the way through different stages of functional tests, until finally, ultimately, you're doing things like capacity and security tests based off your continuous integration tooling. And then the only testing that you really need from a manual standpoint is user acceptance testing. You've got usability testing, maybe some exploratory testing. But largely that can be going along all the time in parallel with the test automation. So you finally get up to the point where you're ready to release, and again, it should be a no-brainer, kind of easy button sort of thing. So this cycle, in a way, it's pretty simple, right? There's a number of discrete points, but it's from a tooling standpoint, you don't have to buy tons and tons of different kinds of tools to make this work. It's, you need a way to manage the backlog, you need a way to do CI, you need a way to do automated testing, you need a way to get environments, and you need releasing tools. So, it's not a huge, technically complex. The biggest barrier that we have is that we've got a lot of ingrained behaviors, and this is why that people part of what Andre talked about is really important, is that you've got to get people to change the way that they work, and that can be difficult. So a couple of these things rely upon some architectural constructs. So with most of this, getting work done in parallel means having a loosely coupled architecture. So loosely coupled architectures enable you to change different parts of the application independently without worrying about the interdependencies, because you've minimized or eliminated interdependencies. So that enables you to do a couple things. One is that you've got APIs for everything, and if you've got APIs for everything, then you can automate testing using those APIs. So API testing ends up being really, really key, and we've got a presentation later this afternoon on, or later on today on continuous testing. So that loose coupling enables independent change, and so these different services, these different components, if you will, can be built independently. They can also be replaced independently. So if you find that something's not performing well, you can rewrite the implementation for it and plug it in. So this thing that's happened in the past, where we've had intricate architectures where everything is perfectly designed and it all fits together like Japanese carpentry, well, the problem is that when you've got that sort of model and you need to change something, then you've got to change everything. And so, the two words that just scare the out of the business are massive rewrite somewhere late in the cycle, where you discovered something that now doesn't perform well or doesn't interact well. So loose coupling is an enabler of automated testing, but it's also an enabler of this responsiveness of change. One of the key things that I like in the Phoenix project that Gene talks about is this idea that maximizing utilization while it's intuitive is wrong. And what we mean by that is that, let's say you've got a siloed organization. You've got business analysts, developers, testers, project managers, architects, operations people. So the way that those organizations are usually managed is to keep everybody as busy as possible, based on the theory that if everybody is as busy as possible and they're working on good stuff, then we'll get the most value out of them. And the reality is that application development is a team sport. I try to not overdo the sports analogies in the time of the World Cup, but basically we can't do anything by ourselves. The time when an individual developer could write an app, or except in maybe some mobile apps in the gaming space, are probably over. But we now depend on other people to do things, and the more complex the application, the more we're dependent upon other people for different kinds of knowledge. Well, when somebody that you need is working on something else, what do? You wait. Or you say, well, gee, I'm going to go work on something else. Well, if you go work on something else, you're creating work in process that might get invalidated once you get the right resource available again. So the best thing you can do is not to maximize utilization, but to maximize throughput. And if you've got scarcity in the cycle, and this is the classic Brent problem in the Phoenix project, you've got one person that's key for everything, they become the bottleneck. So you have to figure out ways to protect that bottleneck and not overload them, and also to spread the work out among other people, reduce the utilization in order to get better throughput. So I encourage you to read that part of the Phoenix project, because I think that's one of the real nuggets and a big change for most organizations. So this moving to maximizing throughput requires a different way of thinking about it. Usually, this is where Agile cross-functional teams come in, but it's also where automation comes in. Why rely upon a person to do something when you can automate it? So the typical benefits that end up being realized from some of these techniques is that as you move from infrastructure as art, and that's basically where every single environment's different, it's uniquely configured, it's manually configured, and to infrastructure as code, which is where you have standard environment definitions that you're basically generating environments based on configurations that you're storing in version control just like code, then the benefit is that, first of all, you reduce a lot of production incidents that occur because the environment between development, test, and production drifted. And this is the classic, it works fine in my environment problem, where you've got a developer develop some code, works fine, tests fine, put it into production, things break. Well, a lot of times that's because, or most of the time that's because some middleware setting was different, or some security setting was different, or port address was different, or something was different. So having identical environment configurations between development, test, and production ends up being key. Now to do that, you have to often use things like service virtualization to simulate the applications that you can't really put in dev or test. You're not going to completely replicate your production environment with all the data in the dev or test environment, but you can use service virtualization and test data management to manage that. One organization I talked to, and this is pretty common statistic, they did an analysis of their of all of their production incidents, and they found that 18% were non-code related. In other words, it related to an environment problem. That's a pretty big number, especially when you look at the cost of production incidents. So infrastructure as code more or less eliminates that. There's always some variables that are hard to replicate. Moving from big batches to small batches and maximizing utilization and maximizing maximizing throughput reduces the waste, basically, in this development process. So we have huge amounts of waste that we can't even see right now. That's one of the problems with software. It's really hard to see the waste. In a manufacturing environment, you see the waste sitting around on the floor. You see it in the scrap bin, or you see the work in process. But it's hard to see that in software. But by being more aware of that work in process, by measuring it, but more importantly, just by eliminating sources of that work in process and that waste, you end up with much better throughput. You end up with much better, in a sense, value from your investment in developing. But to do that, you've got to focus on maximizing throughput. Manual builds to continuous integration, manual testing to continuous testing are really, once you've got reliable environments, these become the engines of continuous delivery. Release automation is important, but the things that you're going to be doing all day, every day, are build, test, build, test. And the smoother you can do that, the faster you can do that, the more effectively you can get feedback, the more effective you're going to be at continuous delivery. So CI is really the engine of this whole process. And then that drives continuous testing as well. So a bunch of benefits derive out of that. And then the last point I was making a few minutes ago is that this moving to a loosely coupled services, some people call this microservice architecture. It's sort of a logical evolution of service-oriented architectures, ends up being key. But even if you're not using SOA per se, you can still use things like basically modularization of components, RESTful services, other sorts of things without maybe all the infrastructure around SOA. But it's really key to move to loose coupling, because that enables a lot of the decoupling and the independent ability to work independently. So as organizations move through this continuous delivery journey, they switch to a different set of measures. So the typical performance measures that they look at are things like cycle time. How fast can we get things out to a customer and gather feedback? Another way of looking at that is the mean time to repair or mean time to respond. So when we have an incident, when we have a bug that comes up in production, how quickly can we fix that and turn it around? So it's another good measure, basically measures the same thing. Some organizations, especially ones that have revenue-producing products or products that indirectly influence revenue, look at revenue per employee, or break it down and look at revenue per application delivery employee. So you'd like that number to go up. You'd like to get more money out of your investment in applications. Technical debt's another good measure, because it measures, in that faster delivery, are you basically cheating? Are you cutting corners that you're simply getting faster now, but it's going to cause a breakdown later on that's going to slow you down? So technical debt ends up being a good measure. Obviously, revenue increases or reducing revenue losses ends up being important from a business perspective. Customer SAT scores, net recommender scores, app ratings are also big aspects of this. So just about every company that's shipping a mobile app is looking at the app score. If you're doing any kind of customer satisfaction surveys, you're looking at is customer SAT going up? Is the net recommender score? Are people willing to tell other people, tell their friends about your product or service? And then innovation rates, the final one that's interesting, is because innovation rate measures the ratio between new stuff to maintenance. So in most organizations, that ratio is about 80%, 70% maintenance work and fixes, change requests, things like that, and only 30% or so, 40% of new things that you're doing. Once you get the feedback loop driving faster, you're doing basically fewer things that need to be fixed later, so that ratio starts to invert. So organizations like, you know, the unicorns, to use Gene Kim's terms, tend to have innovation rates that are around 60 to 70% new things and 30% fixes and changes. So you're doing less stuff wrong that you need to correct later. So to wrap things up, and then we'll have a couple minutes for some questions. So basically, continuous delivery, as we talk to organizations, it's the driver for most of what application development shops, and including now operations through DevOps, are worried about. They're trying to figure out, how do we deliver faster? How do we do that with higher quality? And the paradoxical thing about continuous delivery is that when you get this highly automated delivery cycle, it actually costs less too, because you've got less manual testing. Manual testing doesn't scale well with volume. Basically, it's linear, if not actually declining. You know, there's some diseconomies of scale because of the complexity of organizing large manual testing efforts. So the more you can drive continuous testing, the lower your testing costs. You know, by reducing defects, changing that innovation rate, your costs actually go down. And then by the high degrees of automation that you implement through continuous delivery, it causes other costs to go down as well. So there's less work in process, less effort being used to produce the overall end result, and better quality of results because you get more focus on testing. So all of these things together end up being big drivers for cost reduction, but that's not the main reason why people are doing this. It's sort of an incidental effect at the back end. So cost reduction ends up being key. Continuous delivery also improves quality because you're doing more testing before you release. And in many cases, manual testing in the traditional cycle, you never have enough time to do it anyway. So it ends up being shortcut. You don't have the kind of coverage ratios you'd like to have. And so continuous delivery enables continuous testing, which ultimately, if you follow those practices, you get close to 100% functional testing, and you can start to get into really interesting load testing, security testing, other kinds of automated testing. So all of these things together end up delivering much higher results. And so there have been some interesting things. I'd encourage you to talk to the Puppet Labs folks about their survey of DevOps, because they got some really interesting data in there. Gene Kim was one of the folks who contributed to that. And basically, there's a really high correlation between these sort of practices. In the survey, they call them DevOps practices, but it's really the same thing as continuous delivery. Really high correlations between these practices and better business performance. So this isn't really just about a better technology way of doing things, but it's basically a better way to run your business. And just as a way of concluding, some of the research I'm doing right now is focused on, once you can do continuous delivery, how does that change your business model? How do you use that to drive faster feedback cycles, faster time to market, more innovation because you can make small changes and measure the feedback of that, or measure the effect of that through feedback. And so this is really a revolutionary kind of change that's not just about technology, not just about application development, but in fact is going to be changing the way that business is organized. And that's what we're seeing in those so-called unicorn companies, is they run differently than the traditional organization. And traditional organizations are racing to catch up. So with that, I think we've got some time for questions. Yeah, back there. I think so, yes. They will be available. Yep, exactly. And from there, it's an eye chart. Most of the slides are an eye chart, so appreciate that. Yeah. So I'm looking at total cost to deliver capability to a customer. So to your point, is that some of your costs will initially be higher as you move to loosely coupled architectures. You've got some re-architecting to do. You've also got learning, you've got change, but when you start to measure, once you're doing continuous delivery, the costs are much lower. So if you're looking at a total lifecycle cost for an application or total lifecycle cost for a product, then continuous delivery costs are much lower than the traditional model. Okay. Question back there. Yep. Yeah, probably. Yep. Right. Yep. Yep. Well, and those are the ones I have on the slide, but I've also talked to some others in the financial industry. One organization I talked to a couple weeks ago set up a capital bank in about 2 months. So they've got the same kinds of challenges. Basically what, Jess Humble's got a great phrase for a lot of the problems you run into, security and compliance, and he calls it risk management theater. So the manual approaches of having these review meetings and having inspections and things like that aren't really very effective anyway. So if you build the security testing into your continuous testing suite and also use things like code scanning and app scanning, static analysis tools to look for security vulnerabilities, and also subject it to more different kinds of automated, essentially threat attacks and things like that, then that also frees you up for the manual parts where you can spend more time on the edge cases that are difficult to find. So this also enables a more secure, more compliant model than the manual model. The big challenge we have in switching to that new model is that everybody's sort of comfortable with the manual model. So it would be as if somebody came in and said, we're gonna put a special kind of scanner at airports that all you do is just walk through and we're gonna detect all the risks. Certainly Congress wouldn't believe that that was possible, that you still have to have the manual people there in the system. But actually the manual inspection, especially on security and compliance, is the weakest part of the link. People just don't have enough time to really adequately look at the threats. And so moving to CI and moving to continuous testing enables you to focus automation on the areas where automation is good and basically can catch things, and then frees up the people to focus on the real threats that only a person can look for. Yeah? Question? It's in conjunction. So I think of continuous delivery as sort of Agile 3.0. It uses Agile for the small batch work and process management capabilities, so using the backlog, working in sprints, developing and delivering, doing demonstrations, all those things are great. All the teaming model things are great, but they're not sufficient to really move the needle in terms of business results for the most part. So you need CI, continuous testing, CD, to really change business results dramatically. So it's essentially Agile was necessary, but it's not sufficient in most cases to really make a huge difference, except for sort of involving lots of personal heroics. It does improve quality and improves a lot of things. I'm not trying to knock Agile at all, but in terms of the overall business results and speed of delivery, Agile needs this automation to really be effective. Yep. So some ways of measuring it are to have basically developers be more conscious of when they're making a trade-off and then record the trade-off in the backlog, so at least you have a record of it. That's probably the simplest way. You can also identify technical debt through the static analysis tools and through other kinds of peer reviews. Pair programming certainly can be ways of identifying that. So it's a combination of cultural changes and some instrumentation that you put into the CI process. Yeah, question? Yeah. Yeah. So the challenges around things like an ERP application, or let's just say sort of any legacy system of record kind of application, is that in many cases they weren't designed to be loosely coupled architectures so that you can't modify them. And Martin Fowler has done a lot of work on patterns and a lot of work on refactoring. And one of the patterns he talks about is the strangler pattern. And the strangler pattern basically is, it comes from an analogy around how a strangler fig works. It basically sends tendrils down the trunk of an existing tree and gradually takes root, wraps the existing tree in its own basically biomass, and then eventually that original tree dies off and you have this really interesting looking fig tree. And so essentially by wrapping different parts of the existing applications and services, then you gradually can capture the resources that those services, that the application had, and eventually you can decide whether you still need that ERP system in the background or whether you've got something better to replace it with, but you've broken the dependency chain. One of the big areas that's important in these dependencies is to not use shared databases or shared data at all, but go through a service. Because today your Oracle or whatever database might be fine, but the reality is that schema is tying applications together, and so you can't modify the schema without modifying multiple applications. And if you do it through a service, then it's a logical entity. You don't have to worry about the physical database, and that decoupling starts to benefit you over time. So in the extreme case, you'd like to be able to, as this is just a way of testing, do you have enough loose coupling in the data? Could you pull out Oracle and put in Hadoop? If you could, then you've really achieved high degree of loose coupling in the data. Data is not the only area, but it's a big area. So anyway, other questions? Yeah, one more. Yep. Yeah, so for those of you who might not have been able to hear it, so, and I'll paraphrase a little bit, the testing ends up being one of the major bottlenecks in this whole process, because if you're doing really rapid builds, you want to get quality feedback on that build quickly. And if you have to subject it to manual testing, that can be weeks, days, weeks, months. So there's a big shift in this continuous delivery model from a manual testing model to automated testing. But it happens basically service by service, interface by interface over time. So what the big change that's necessary is to do one of two things. One is to give developers more time to write automated tests and not overload them with the new development work. Or the second thing is to gradually start hiring a different kind of developer. And so one organization I talked to, their new college hires coming into the organization were put into a test automation engineer role. And so what they did is that they wrote code, but what they were doing is writing code against somebody else's APIs to test that. And they would use pair programming and some other things to help learn how things should work. But basically they were writing the test cases. Well, over time, you get more and more coverage through that, and less and less, and there's less and less need for the manual testers. And at some point, the organization can start to make decisions about shifting resources from manual testing into this test automation engineer kind of role. But it's a gradual change. The nice thing I like about almost all of these techniques is that you don't have to do big change to get them implemented. You can just start chipping away at the problem, and eventually you get there. But that is a big bottleneck, and until this is the problem that Agile had, is that it's great, you can develop in sprints, but then if it takes you 3 weeks to get testers to work on it, then the value is all lost. It can be as simple as basically the carrot. In other words, saying you will do it, and we're going to measure you not only on the code you deliver, but did everything have a unit test? And you just make that part of the check-in process, and you bounce it back until it works. That's kind of draconian. The better way is usually to use peer pressure. People are amazingly respondent to peer pressure, and so you find somebody who exhibits the right kind of behaviors, and you sort of put the spotlight on them and say, Sue's doing a great job on this. This is really fantastic stuff that she's doing. How are you doing that? She, I'm doing this through automated testing, and it uncovered that thing, and other people go, maybe I could do that. So it's a combination of carrot and stick in a sense. Yeah, back there. Yeah. Yep, yep. Yeah, that's a great point. It's that we found that this change in organizations, it usually starts with an engineer who wants to work in a better way, who says, you know what, this just is really, we can't keep doing this. And so they convince a few of their friends who convince a few of their friends, and so on and so on. So it's often bottom up to a point, and then you need top-down leadership to really support the larger scale changes, but it starts usually with a groundswell. Yeah, question back there. Are there tools to do unit testing better? Yeah. Yep. Yeah, and I think that's a topic that would be good to bring up on the session on continuous testing as well. But you know, there's certainly some of these things are just good coding practices and good development practices that need to get socialized in the organization. Some of it's tooling that supports improved unit testing and ultimately then scaling that up. But a lot of it is back to the other gentleman's point, the passion for doing it, the realization that this is just the way that software is built, and that if you're not doing it, somehow you're not a good developer, you're not a good engineer. And I think we might be run out of time, so certainly be around at lunch and later and the breaks if you have any other questions.
Thanks, Kurt. Great job.